Hello, my viewers. Welcome back. This is your teacher Pascal or Mr. Distinctions. If you are new to the channel, kindly subscribe. This is because on this channel, we do not have only chemistry, but we learn all the composite subjects. We learn mathematics, biology, chemistry, as you can see, English, and also physics. Therefore, I urge you to subscribe to the channel because you'll be having all those lessons through this same channel. And the other thing, I just want to encourage the grade 12s who will be writing their final examinations in this year. Just keep on studying hard and smart. Everything will go on for sure, you will pass. Also, to help you, I have created a WhatsApp group where I usually share some important materials which I was using and which helped me very much to obtain good results. So you can just send me your message. You can just send me a message so that I can add you to that same WhatsApp group. Okay, so you can use my number 0976 58 98. Okay, you can just use this same number to send me a message so that I can be able to add you to that group so that you can have some important materials which actually will help you very much, especially in these last days. Okay, so let us dive in today's topic. So today we will be just talking about chemical formulae. As you can see, this subtopic is very important in such a way that it can actually affect your results, especially when talk of chemistry, because almost every topic has got this part, and for that reason you need to understand it very well. Okay, so when talk of a chemical formula, what is a chemical formula? Maybe that is a question. What is a chemical formula? Or before that, this subtopic, as I said earlier on, is very important. And why am I saying so? This topic is very important because for you to identify compounds and molecules, you need to understand this topic. Also, for you to determine the molecular structure of a certain compound or molecule, you need to know this topic. Not only that, this topic also, or subtopic so to say, helps a lot in calculating the molecular masses of different compounds and molecules. So, if you do not know how to write chemical formulae, you would find that you cannot even calculate what molecular masses. Not only that, most importantly, this subtopic helps to write balanced chemical equations. If you do not know how to write chemical formulae, it means you cannot even write a balanced chemical equation, because when you have been asked to balance a certain equation, you need to know the chemical formulae which are in that particular uh, equation. So for you, let's say for example, maybe you have been given a word equation and they have asked you to write a balanced chemical equation. You need to know how to write it, how to interpret that word equation into chemical equation. And for you to interpret that word equation into chemical equation, you need to know how to write chemical formulae, because chemical formulae are the ones we use to write chemical equations. And for that reason, if you do not know how to write chemical formulae, you cannot write any chemical equation. You cannot write any correct chemical equation. Of course, maybe you can write a chemical equation, but it may not be correct. So you can see how important is this subtopic. That's why I thought it very important to share this video so that you can understand fully how to write different chemical formulae. And if you understand that, you'll be able to write different chemical formulae. And writing balanced chemical equations will will cease to be an issue. Okay, so I urge you to watch this video up to its end, because I will guide you step by step on how to write different chemical formulae. And once I show you the procedure, I'm sure you'll be able to to write any chemical formula of any compound or molecule. All right. So maybe we can ask ourselves to say what is this same chemical formula. So when you talk of a chemical formula, we're just talking about a symbolic representation of what of a chemical compound's composition. So when talk of a chemical formula, we are talking about a symbolic. We're talking about a symbolic what? Representation. A symbolic representation of what? A symbolic representation of a chemical compound. Of a chemical compound what? Of a chemical compound's composition. I'm sure you can finish that definition. My board is small, as you can see. So we are talking about a symbolic representation of what? Of a chemical compound's composition. Let's say, for example, maybe you have been given a certain chemical compound. So that chemical compound is composed of different what? Different atoms of different elements. So now, when we talk of atoms have got symbols. Let's say, for example, when we talk of hydrogen, hydrogen has got a symbol which looks like this. So we use these same symbols to represent a certain what? A certain chemical compound. So now that symbolic representation of a chemical compound's composition, that is what we are calling a chemical what? A chemical formula. I'm sure you're getting it. So let's say, for example, let me just give you another example so that you may comprehend fully this definition. Okay, let me just clear this part. All right, so let's say, for example, you've been given water. So what you are simply saying that a chemical formula is a symbolic representation of what? Of a chemical compound, or of a chemical compound's composition. So here we've got this molecule, which is the water molecule. So now, as you can see, this water molecule is composed of what? Different atoms of different what? Elements. So now, I'm sure you can be able to see that here we've got this hydrogen and here we've got this oxygen. So these are the symbols we are talking about. These are the symbols we are talking about. A symbolic representation. This part is explaining this. Now, a symbolic representation of what? Of a chemical compound's composition. So you can see that in this molecule, we've got this molecule is composed of one hydrogen, two hydrogens. Then we've got what? One oxygen. So we've got two hydrogens, then we've got what? One oxygen. So that is actually what a chemical formula is. Okay, so these chemical formula are very important, as I said earlier on, because they help us to write different chemical balanced equations. Not only that, for you to calculate any molecular mass of any molecule compound, you need to know this, because you'll be taught to calculate the molecular mass of hydrogen, carbon dioxide, and maybe they will just give you a word equation to say carbon dioxide reacted with, or an acid reacted with this certain compound, then these are the products, and among the products, carbon dioxide was there. Then they will ask you to calculate the molecular mass of carbon dioxide. And we all know that for us to calculate any molecular mass of any molecule, we need to know how to write chemical formula. Because if you write chemical formula, this chemical formula is going to tell us how many oxygen are in this chemical formula, and also how many carbons are in this same chemical formula. And since we have got 2, we are going to write 2 and its atomic mass, which is 16. Then here we've got 1 carbon and its atomic mass, which is 12. So 12, 1 times 12, the answer is 12. Then 16 times 2, the answer is 32. So you can see that carbon dioxide has got 32 plus 12. Actually, this is 44. So this is the molecular mass of carbon dioxide. So as you can see, for you to find this molecular mass, you need to know how to write these molecular formula. Not only that, these chemical formula, as I said, help us to determine the chemical structure. So as you can see, the chemical structure of carbon dioxide. Okay, let me just give you this example, or maybe I'll give you some examples that will be going through this topic. Okay, so that is basically what a chemical formula is. Alright, so I want you to understand this, and the first thing I want you to understand is what a chemical formula consists of. So when we talk of a chemical formula consists of 2 things. Number 1, a chemical formula consists of a symbol or symbols, so to say, symbols of what? Of elements present in that particular chemical formula. So a chemical formula consists of what? Symbols of elements. Okay, so let's say, for example, we've got water. So this water, as you can see, has got these symbols of what? Of elements. We've got hydrogen, we've got also what? Oxygen. Maybe the other example, let's assume you have been given this is methane. So as you can see, we've got this symbol, which is a symbol of carbon, and also we've got this symbol, which is a symbol of what? Of hydrogen. Okay, then the other part, when we talk of chemical formula, any chemical formula, as I said, consists of number 1, symbols of different elements which are present in that chemical formula. Then number 2, any chemical formula consists of what? Subscripts or small numbers. Okay, any chemical formula consists of what? Subscripts or small numbers, indicating the number of what? Atoms present of each element. Let's say for example we've got carbon dioxide. So in this chemical formula, we can see that here we've got this carbon which has got no number right over here, and for that reason we know that since we have got no n number right over here, this carbon, we've got only 1 carbon in this particular molecule. Then here, as you can see, we've got these 2, and this shows us that this molecule has got how many oxygens? Has got 2 oxygens. The other example is the same example I gave, methane. So we can see that we've got this number, this small number. This is the number we're talking about, or a subscript. So this number shows us that in this particular chemical formula, we've got 4 hydrogens. I'm sure I'm getting the point. Okay, so that is what actually each chemical formula consists of. All right. So now let's now see how we can come up with these different chemical formula. Don't forget to subscribe if you haven't yet done that. Also, I urge you to watch this video up to its end because I want you to understand this particular topic. Okay, so now how do we write different chemical formula? Okay, let me just grab the board. Okay, here's a question. How do we write different chemical formula? Okay, so I'm going to give you some examples of different chemical formula. Then I'm going to explain step by step how we can come up with such different chemical formula. Okay, so the first chemical formula I'm going to show you how to write, and I know that if you know how to write, if you be following me step by step with these few examples I'm going to give you, you'll be able to write each uh, chemical formula. So let's say, for example, we've been given carbon dioxide. This is a chemical formula, as you can see. Okay, this is a chemical formula, as you can see. So now, how did they come up with this chemical formula? How did they know that the chemical formula for carbon dioxide looks like this? All right. So how do we write uh, this? How do we write this chemical formula for carbon dioxide? Well, so just keep on following me. I'll guide you through step by step, as I said earlier on. So for us to write a chemical formula of carbon dioxide, remember this procedure I'm going to show you is a procedure we use to write any chemical formula. Any chemical formula. I'm just giving you these examples so that through these examples you may understand well. You may understand well. When I talk about the chemical formula of carbon dioxide, I do not mean that each and every molecule has got its way or method of how to write that its particular molecular formula. I hope you are getting that point. When I say that, let us look, let us look at how we can write a chemical formula for this particular molecule. I do not mean that each and every molecule has got its method of writing chemical formula, but I'm giving you these examples so that you may comprehend fully. Through examples, I know you can understand very well. And this is a method. This same method I'm going to show you, the same method we'll be using to write any chemical formula of any compound or molecule. And after finishing learning this, I urge you to try to write some different chemical formula. Okay, so this is carbon dioxide. How did they come up with such a chemical formula? So the first step, for you to write a chemical formula of any molecule or compound, you need to know the atoms or the elements present in that particular molecule. What do I mean? Let's say, for example, we have been taught to write a chemical formula of this molecule. This is actually carbon dioxide. So what I mean is that you need to know the compounds. I mean, you need to know the elements which which comprise carbon dioxide. So in this case, we know that in carbon dioxide we have carbon and we have oxygen. So these are the elements we have which are present in what? In carbon dioxide. we have carbon, also we have oxygen. I'm sure you're getting the point. Okay, so these are the elements which are present in this particular molecule, carbon and also oxygen. So now, besides that, you also need to understand, or you also need to know the valences of each and every element. You need to know the valence of carbon, you need to know the valence of what? The valence of oxygen. But maybe you can ask, what do I mean by saying you need to know the valences of each element? So when talk of a valence, when talk of a valence, okay, when talk of a valence, we're just talking about the number of electrons which are shared, which are gained or lost for an element to be stable. We're talking about the number of electrons which are lost or gained for an element to be stable. Let me give you an example for you to understand it fully. Let's say, for example, we've got this same oxygen. Okay, oxygen is uh, is on number, has got 8 as its proton number, and here oxygen has got 16 as its mass number. So if you can write its if you can write its okay, sorry. So if we can write its electronic configuration, we can see that oxygen looks like this: 2, 8 minus 2, here we've got 6. So this is the electron configuration of what? Of oxygen. Now remember, we have been told that for each and every atom to be stable, for an atom to be stable, that particular atom has to have 8 electrons in its outermost shell. And if you can see here, in the outermost shell of oxygen, we've got 6 electrons. And for that reason, this atom is not stable. Now, what will happen for to this atom for it to be stable? It has to find more 2 electrons, because if it finds 2 more electrons, that's when we are going to have 8 right over here. So for this atom to be stable, has to gain 2 more electrons. So that same electrons are the ones which are calling valences. So in this case, we are saying oxygen will gain 2 more electrons for it to have 80 as the number in its outermost shell. So remember, by definition, when we talk of a valence, we are talking about the number of electrons which are gained or lost. Which means that there are some elements which gain stability by gaining electrons. For example, this oxygen, for it to be stable, it has to gain 2 more electrons. So this oxygen, this atom of oxygen gains stability by gaining what? Electrons. So how many electrons does it gain? 2 electrons. So that same 2 is the valence of oxygen. Let me give you another example. Let's say, for example, we have been told to find the valence of magnesium. So the first thing you need to do, you need to know the proton number of magnesium, because proton numbers are the ones which determine the electron configuration. So carbon is on number 12. Then carbon has got 24 as its mass number. Okay, so we are going to use this same 12 to write its electron configuration. And we know in the first shell we need to have 2 electrons. So here we've got 12. 12 minus 2, the answer is 10. But again, what you need to understand is that in the second shell, the second shell is limited to just to have 8 electrons. So here we've got 8 electrons. So if magnesium was like this, then we would have said magnesium is stable. But we can't say that because magnesium has got 12 protons. And here we've written just 10 protons, which means that we have remained with another 2 protons, of which we have written right over here. Okay, so maybe let me make you clear on this point. When I say protons, protons are the ones which we normally use to write electron configuration. What I mean is that um, we learn that n atom, n atom is neutral. Reason why? Because n atom has got the same number of protons and the electrons. And for that reason, if you have been told that this magnesium is an atom, is a neutral atom, it means the same number of protons we have is the same number of what? Electrons we have. Why do I say so? When writing electron configurations, we use electrons, not protons. But if you have been given n neutral atom, let's say, for example, in this case, we have not been given electrons. We have only been given this mass number and the proton number. So now, what are we going to use to write this electron configuration? So that's why I said that we are going to use this proton number. A reason why? Because we have understood that the number of protons is the same number of what? Electrons in a neutral atom, so to say. All right, I'm sure you are clear on that one. Okay, so as you can see, here magnesium has got 2 electrons in its outermost shell. But remember, it has got this 8, and what we need is an atom to have 8 electrons in its outermost shell. So here we've got 2 options. It either we remove these 2 so that we can remain with this 8, or we find another 6 electrons so that we can add those electrons to these 2 so that we can have 8 electrons in its outermost shell. But as you can see, it is very simple for us to just remove these 2 so that we can remain with this 8, than to find 6 more electrons. So what we are going to do, we are just going to clear these 2, and here we've remained with 8 electrons in the outermost shell of what? Of magnesium. So for what has made magnesium to be stable is by removing that 2 which was in the outermost shell. So since these 2 were the one which was damaging the stability of this element, then we can say that magnesium has got 2 as a valence. I'm sure I'm getting the point. For magnesium to be stable, has to lose 2 electrons. That's why by definition I mentioned of 2 things. When we talk of valence, we are talking about the number of electrons which are loosed, and in this case, magnesium has loosed 2 electrons for it to be stable, or gained. In the case of oxygen, for oxygen to be stable, has to gain more 2 electrons. I'm sure you are getting the points. Okay, so that is that. Maybe I will make a video just to explain how to write different electron configurations. Okay, so we need to understand and to know the valences of these 2 elements. So when we talk of oxygen, oxygen is on number 6, and the oxygen has got 12. as a mass number. Then I mean this carbon. Carbon has got is on number 6 and has got 12 as its mass number. Then on top of oxygen, oxygen is on number 8, has got 8 as its proton number. Then 16 on top. Okay, so I'm sure I can write now the electron configurations of these two elements so that we can determine their valences. So when talk of oxygen, we are going to use this proton number, knowing that the same number of protons is the same number of what electrons, since this is a neutral atom. I hope you are getting that. So we all know that in the first shell we have to write 2. Then in the second shell, here we've got 6. If you subtract 2 from this 6, you are going to remain with what? With 4. So for this oxygen to be stable, has to have 4 more electrons, and that is its valence. I'm sure you are getting the point. So that is its valence. So the valence of carbon is what? Is 4. Okay. So what do we do when we find the valence of a particular element? When we are writing chemical formula, immediately we find the valence of any particular element, you need to write on top there. Okay, let me just show you. You need to write it on top there. Then let's also find the valence of this oxygen. So oxygen, as you can see, has got 8 as its proton number, and due to the fact that this is a neutral atom, also the number of electrons is 8. So here we've got 2. 8 minus 2, the answer is 6. So for oxygen to be stable, has to gain more 2 electrons, because if you add 6 plus 2, we are going to have 8. So that number of electrons which are gained for this to be stable, and in this case which is 2, is the valence of what? Of oxygen. So finding that, you are going to write it on top there. I hope you are getting the point. So now, what is the next step? After writing the valences on top of each particular atom, what you need to do, you need to swap. Okay, sorry. So what you need to do, you need to swap what? The valences. You need to swap the valences. I hope you are seeing that. You need to swap the valences. So if you swap, you will find that what you are going to have is carbon with these 2, and also oxygen with these 4. I hope you are seeing it. So now, if you can see this formula mathematically, we can see that both of the numbers we have are even numbers, and 2 can go into 2. Also, 2 can go into what? Into 4. So what are we going to do? We are going to divide both sides by. We are going to divide both numbers by 2. So if we divide 2 by 2, we are going to have 1. And in this case, we do not write 1. And if you divide 4 divided by 2, what we are going to have is what? Is 2. And this is how we write the chemical formula for carbon dioxide. I'm sure you are getting the points. Okay, let me give you another example. Let's try to write the chemical formula of water. We know that water is H2O. So how do we come up with this chemical formula? Well, so remember the steps. We write the atoms of the elements which are present in that particular element. In this case, we've got H and we've got oxygen. What is the next step? We are going to write the valences of each what atoms of these elements. What is the valence of hydrogen? Hydrogen we know is on number 1, and for that reason that is the same, that one is the same valence of hydrogen. Then what is the valence of oxygen? You have just from talking about oxygen. Oxygen, as you can see, okay, oxygen, as you can see, its electronic configuration is 2,6, and for it to be stable it has to gain more 2 more electrons, and this 2 which is making this oxygen to be stable is the one which are calling a valence. So we are going to write it on top there. Remember, when you are writing these valences, we need to write them on the right hand side, on top of your right hand side. As you can see, this is the right hand side of this hydrogen, and this is the right hand side of what, of this oxygen. So after writing that, you need now to swap them. You need to swap them. So here we've got hydrogen, and these two which has come here. Then we've got what, oxygen, which is right over here, and this one. And in mathematics we do not write 1. Okay, so this is how we normally write the chemical formula for what, for water. Okay, let me give you another example. Let me give you another example so that you may understand fully. The other example, you're going to look at sodium chloride. Okay, so in talk of sodium chloride, we've got how many elements, or how many atoms of elements? We've got sodium and what, chlorine. I'm sure you're able to see. Okay, let me just write it well. We've got sodium and we've got what, chlorine. So if you can see, we can see that in this particular compound we've got these 2 elements. We've got sodium and we've got what, chlorine. These are elements which we have in this particular compound. So we are going to write sodium, and we are going to write its electron configuration. So sodium is on number 11, and its mass number is 23. And by the way, I would encourage you to master the first 20 elements. I would encourage you to master the first 20 elements. What you can do, you can just write them on the paper, then you stick that paper somewhere so that you can be able to see the elements each and every day. It is very important to master the first 20 elements. As you can see, I'm just writing different elements and knowing their proton numbers and mass numbers because I labored to master them. Okay, so sodium is on number 11, then its mass number is what? Is actually 23. Alright, so here, if you were to write its electron configuration, we are going to use protons, knowing that the number of protons and electrons is just the same since this is a neutral atom. So we have 2, 11 minus 2, we've got what? 11 minus 2, we've got 9. But remember, the second shell has to have only 8 electrons. So as you can see, we've got 8 right over here. Then lastly, if you add 2 plus 8, the answer is 10, and what we are going to remain with is 1. So you can see that for this atom to be stable, it has to lose this electron, because it will be more difficult for it to find 7 more electrons than just to lose this 1 electron. I hope you are getting it. So this same 1 electron which is being lost for this element to be stable is its valence. So we are going to write it like that. Then we've got also chlorine. We've got also chlorine. Chlorine is on number 17, and its mass number is 35.5. Okay, so we are going to use this. I hope you have now understood why I'm using proton numbers. Okay, so its electron configuration is 2. Then we've got 8. Okay, here we've got 17. As you can see, if you add 2 plus 8, the answer is 10. So 17 minus 10, the answer is what? 7. So now for this element to be stable, as you can see, it has got two options. It can gain one more electron or lose these 7 electrons. But what will determine, or what will be what will be is just to gain one electron than to lose these 7 what electrons. And for this reason, we are saying this element, which is chlorine, gain stability by gaining what electrons. And in this case, or in every case, chlorine gains only one electron for it to be what to be stable. And this is its valence. I hope you have denoted the differences between these two elements. Of course, both of them have got the same number of valence, but this one is having this one because this one is it is very easy to find this to gain stability by just adding this one to this 7 which we have been given. It is not easy for it to lose these 7 electrons than to what to gain than it can be easy to gain just one electron. But when we talk of sodium, as you can see, sodium, we said that its electron configuration looks like this. And as you can see, it is very difficult for sodium to gain more 7 electrons than to lose what? This same one electron. So from this, we can differentiate a metal from a non-metal. Whenever I just see that an element is losing for it to be stable. Like in the case of sodium, sodium is losing this one for it to be stable. Just know that that element is a metal. I hope you are getting that. Whenever you see any element which is losing for it to be stable, just know that that element is what? Is a metal. And which are what some of those elements? Okay, so when you see any element which has got 1 as sodium, or 2 or 3 in its outermost shell, an element which has got 1 or 2 or 3 in its outermost shell, in its last shell, the outermost shell, just know that that element is a metal. Because as for this one which has got 1, it will be very easy for it to lose this one than to gain what? To gain 7 more electrons. Again, if you look at this which has got maybe 2, let's assume that we have 2 here. It will be also very easy to lose these 2 electrons than to gain 6 more electrons. Also, when you look at this one which has got 3 in its outermost shell, you will find that it will be very easy for it to lose what? These 3 electrons than for it to find more 5 more what? Electrons. So from this point, we say that all metals lose. Always a metal loses, while a non-metal gains. I hope you are getting that. I will explain further in the next topic, where we'll be looking at different types of chemical bondings, because these are key principles which are there. If you haven't understood this, then it will be very difficult for you to understand that topic, which is called bonding. So I urge you to keep on checking so that you can understand that particular topic. Okay. So as we are doing, we are going to swap the numbers. So here we've got sodium with this one, and we've got what? Chlorine with this one, and our chemical formula will look like this. And this is how we write what? Sodium chloride. Okay, maybe the last example which I can give you before I I write the procedure. I'm going to write the procedure. Don't worry, because I know that maybe you can forget. So I'm going to write so that you can copy in your book. You keep on revise so that you can keep on revising. Okay, so the other example I'm going to give you is a compound for magnesium oxide. Okay, magnesium is number 12. Then here it has got what? 24 as its mass number. So its electron configuration will look like this. Since we have got 12, 2, 8, 8 plus 2, we're going to have 10, 12 minus 10, we're going to have 2. And as you can see, for it to gain stability, it will be very easy for it to to just lose these 2 electrons than to find 6 more electrons. So from this point we can see that magnesium is a metal, because remember, metals always do what? Lose. So this same number which is loosed, for it to be stable, is the one we are calling the valence, and you are going to write it on top there. Then as for oxygen, I'm sure you have now understood or you now know, its valence. The valence of oxygen is 2. Okay, so now what are we going to do? What we are going to do, we are going to swap the numbers as we are doing. We are going to have this. So as you can see, these are what? These are even numbers. So they are going to cancel themselves, and then our compound will look like this. I hope you are getting it. Okay, maybe the other example I give you the before I give you the notes, some few notes. The other example is the compound of aluminum oxide. The compound of what? Aluminum oxide. This is how we write the chemical formula for aluminum oxide. But how do we write this? Just do the same procedure. Aluminum is on number 13. Here we've got 13 as its proton number. So we are going to write 2, 8, what? 3. Okay, in some books you find that they are putting like this. Just one and the same. I don't know if maybe there are some complications about this, but when I was in grade 10, 11, 12, I was using commas instead of these dots. But these also are also good. You can use them if that is in your case. Okay, so as you can see, we've got 3 in the outermost shell of what? This aluminium. And remember what I said, from this point you can identify if this is a metal or a non-metal. If this element is losing or gaining, for it to be stable. And we can see that it will be very easy for this element to lose what? These 3 electrons than to gain what? 5 more electrons. And for this reason, we can see that always aluminum loses. And due to the fact that it loses, then it's a metal. I'm sure I'm getting the point. Okay, so actually this is the valence of what? Of aluminum. So we're going to write it like that. Then oxygen, as for oxygen, I opened guess that you know. As for oxygen, we can see that we've got these 2 and we've got these 6. Oh, sorry, not 16 but 8. Okay, we've got these 2 and these 6, and as you can see, it will be very easy for oxygen to gain 2 more electrons, because these are few, than to what? To lose 6 electrons for it to remain with these 2. Mind you, if it remains with 2 in the first shell, it is also a stable what? A stable atom. though the rules they obey are the ones which are different. If an element is stable, gains stability by having 8 electrons in the outermost shell, like in this case where oxygen will gain 2 more electrons, and it is going to have 8 electrons in its outermost shell. Then this atom, which is oxygen, obeys the rule which is called the octet rule. I hope you are getting that. But if an element gains stability by having 2 electrons in its first shell, let's say for example we've got an element uh, helium, which has got 2. So helium has got what? Has got 2 electrons. Sorry, let me just clear this part. Helium has got 2 as its proton number, of which, if it has got 2 protons, it means it has got what? How many protons? How many electrons? 2 electrons. So if you write its electron configuration, you're just going to have 2, and the first shell has to have 2 electrons. So this element, or this atom, so to say, which is helium, not H but He, which is helium, is stable because it has got the maximum number of the first shell. The first shell has to have 2 electrons, and aluminum has got 2 electrons in its shell, because aluminum has got only 1 shell. So this element, or this atom, so to say, this atom is a stable atom. But the rule it obeys is different from the one which obeys oxygen. Oxygen is stable. Oxygen becomes stable when it gains 2 more electrons. And if an atom gains stability by gaining 2 electrons, or a number of electrons, if an atom gains stability by having 8 electrons in its outermost shell, then that atom obeys the rule is called octet rule. But if an atom gains stability by having 2 electrons in its first shell, because we know that a first shell has to have 2 electrons, then that particular atom is stable, and the rule that particular atom is obeying, we call it a duplex rule. A duplex rule. Okay, so what I'm saying that any element which gains stability by having 8 electrons in its outermost shell obeys octet rule. But any atom, such as helium, which gains stability by having 2 electrons in its first shell, an atom which has got uh, only 1 shell, and that particular atom has got 2 electrons, then that atom is stable. By the rule that atom obeys is different from the ones which the one which is obeyed by atoms which gain stability by having 8 electrons in their outermost shell, and that rule we call it duplex 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 rule. Okay, we call it duplex rule. So when talk of duplex, goes with 2. When talk of octet goes with what? Goes with 8. I hope you have gotten that. Okay, so oxygen, as we have said earlier on, oxygen has got 2 as its valence. So we need to just swap them, and what we are going to have is okay. So now this is a point. That's the reason why I even added this to be an example. This is a point. Here we've got different numbers, and in this case we cannot divide them. We only divide them if we have numbers which can be divided. But 2, of course 2 can go into 2, but 2 cannot go into what? Into 3, because we are going to remain with some remainders. So just write it like this. That's all. Okay, I hope you have gotten the point. Let me just give you the procedure of writing different chemical equation and chemical formulae as we are doing. Okay, so the first point, identify what the mentioned elements. So you need to identify the mentioned elements of that particular uh, molecule compound. Let's say, for example, if they say carbon dioxide, it means we have got carbon and we've got what? Oxygen. If they say magnesium oxide, we've got magnesium and oxygen. If they say water, of course we know that we've got hydrogen and we've got what? We've got oxygen. So we're going to list them. We're going to write them. We're going to identify the mentioned element. Then we are going to write them. We are going to write the symbols of the mentioned what elements. Then number two, after identifying the mentioned elements, what you need to do now, you need to find the valences of each atom of that particular element of that element. Let's say, for example, I've been taught to find the chemical formula for carbon dioxide. We are going to write carbon and the oxygen. This is the first step to identify the mentioned elements. Then we are going to write the valences. I hope you know now how to find different valences of different what atoms. So we are going to write valences on on the on the top on the top of the right hand side. So we are going to write it like this. I hope you have understood this by now. Okay, then number three, after writing the valences, what you need to do, you need to now to swap the valences. If you swap the valences, if you can divide them, let's say for example, we've got we've got 2 here, then we've got 4 here. Let's assume we have got this element and this element. We've got 2 here, we've got 4 here. We can divide. Or let's say for example, we've got we've got which other example can I give? Okay, maybe just in this case, we've got 2 here, then we've got or maybe we've got 2 here, then we've got also another 2 here. We can divide. Or another example, maybe we've got 3 here, also we've got 3 here. You can do what? You can divide. But if you got different numbers which cannot be divided, let's say for example we've got 2, then here we've got 3. Then you just have to leave this chemical formula. This, do not attempt to divide, because you are going to find that if you divide 2 to 2, 2 by 2, you're going to have, of course, 1. But if you come to this one, you're going to remain with what? With a remainder. And so far, I haven't seen any chemical formula which has got uh, its subscriptive, which has got a decimal number. Okay, I hope you have understood the topic. Otherwise, thank you very much for watching. Also, don't forget to subscribe. Also, don't forget to share. In the next video, we'll be talking about chemical what? Chemical bonding. This is our next chemistry topic. We'll be looking at. If you have any questions, you have any comments, you can just put them. You can just write them in the comment box. Otherwise, thank you very much. Don't forget to subscribe and also share to your friends so that they may also understand this, because you are all fighting for passing your final examinations. As for now, thank you very much.